Okay, so 9-1 and 9-2.
Oh, we're doing.
Oh, sorry, Justin, did you need me to not erase that?
No, it's fine.
Okay. So 9-1 is inverse and joint variation. Here's the idea behind it. Joint variation, or excuse me, direct variation is always going to have this format. There's y and x, and the only difference between them is that x is increasing at a rate of k compared to y. Does this make sense?
Mm-hmm.
So if you're thinking about a graph, it's always going to pass through the origin because the y-intercept like plus 0, right? Right. Are you like zoning out?
I've got it.
Okay. Good. So the only thing you need to worry about in these is what is k, because x and y are going to obviously stay in the equation as x and y.
Mm-hmm.
K is the only thing that's going to change.
Okay.
So they can tell you something like, let's see. Find an actual problem because it doesn't look like they have any. We don't have like any. That's weird. Okay. So they can say something like y varies directly with x, and when y is 5, x is 2. What is x when y is 30? So, if we know that they vary directly, we can immediately plug them into here, because the only thing you're looking for is k. Okay. So, y, when y is 5, x is 2. So just solve for k. K equals 5/2. And now we know that our equation is y equals 5/2 x.
Wait, what? Where did the k is 5/2?
Uh-huh.
Something I don't.
Oh, I see.
I don't get it. For the y equals 5/2 x. I don't know how you got that.
Because y equals k times x. But k is 5/2. So we're just putting that in.
So you plugged in the original values
like-
that they gave. Okay.
It's like putting in 2 pairs of coordinates. So it's like 5
Yeah.
is the first coordinate.
So in
Right.
that case, then
X,
we
Y.
solve for x when y is 30.
Right. And so you'll always have 2 steps to these type of problems. You will have to find k, and then you'll have to find something else. So now that we know what k is, y is 30. 30 equals 5/2 x. So we just need to solve for x. Multiply both sides by 2/5. And x is 12.
Nice. I said nice.
Okay, so this makes sense.
I like these.
So
Finally.
this is direct variation. You also have indirect variation. K is always in the same spot, by the way. So it's always y equals k. Or if they tell you a different variable, it doesn't always have to be y, it could be z varies directly. So then it would be z equals k. But if z varies indirectly with x, it's still z equals k. You just put x in a different spot. Does that make sense?
Yeah.
So this is indirect.
I think this is a really, I feel like I've seen so many of these on SAT stuff, right? In the
Yeah.
word problems. So
Yep.
it's like, if you know what direct and indirect variation are, it's so easy to just get that problem. But if you don't, then it's
a
like,
little confusing. Yeah.
you have no idea what you're talking about.
So here we would say, like, the variables x and y vary inversely. So variables x and y vary inversely. and when y equals 8, x equals 3.
So solve for k first.
Right, so the first thing you need to do is solve for k. And then it says find y when x is negative 4. So y equals k over x because they said inverse variation. So we know it's going to be this one. So when y is 8, 8 equals k over 3. So just solve for k. K equals 24. So our equation is y equals 24 over x. So to find y when x is negative 4, we just plug in negative 4.
How that?
So y equals
I
negative
was like,
6.
how do you get that?
In that voice.
Oh. Yeah, exactly that voice in my head.
Does this make sense?
Yes.
Excellent. So the last type of variation is called joint. And joint just means you have more than one happening together. So you can have joint variation like y varies jointly with x and z. It doesn't matter though, it's still always going to be y equals k. K is always in the same spot. Or you could have y varies inversely and jointly with x and z.
Okay.
Does that make sense? So joint variation just means that you have more than one variable on this side. But k, once again, always in the same spot.
But they have to give you enough information to solve.
They always do.
Right?
Right.
So they're going to give you something for either k or z.
Yes.
Right?
They have to.
So in the end, you're only going to end up having one variable either way.
You have to. To have, yeah. Mm-hmm.
Oh, you know what?
What?
Can't this be applied to, like, if you have two variables, you need two equations to solve it? Like, could you apply this to systems?
You could, but that doesn't usually happen.
Okay.
They don't normally require you to do that because they're. But I like where your head's at. Good job.
Okay,
I was just scared that it could get a lot harder really fast.
Yeah, you're like, wow,
this
escalated quickly.
This is like basic algebra.
Yeah,
right?
we're gonna switch gears a little bit as soon as we're done with this. We're almost done with 9-1.
Does it escalate very quickly?
Yes. But not until Monday.
Okay, I was like 9.2, just the hammer comes down.
No.
I'm like, not ready for
9.3 is gonna be a little bit challenging.
Okay.
So Thursday and the weekend, we're doing just the test and 9.1?
Test
And
9.1 to
9.2.
9.2.
And 9.2?
Yeah, if you can't get it done, just let me know because
Okay.
I think I'm pretty understanding about that kind of stuff.
Okay.
So, but if the goal is for you to finish by Monday.
Finish 9.2 and the test through 9.2 and the chapter 8 test by Monday.
Right.
And we
'Cause
still have another
normally-
week before spring break, so we're gonna.
Yeah, and normally when you have the test, you also have the chapter review at the same time. But you already have the chapter review done.
Mm-hmm.
So it's very rare that you guys ever have homework or no homework in combination with the test.
Okay.
Yeah.
So it should be just about the same.
Yeah.
Okay.
So
Alright.
then would this be like would they say like, if they add another variable, would they say like it directly,
Yes.
and then it'll say it inversely
They can say something
relates,
like,
whatever. So then you know that it'd be a fraction.
if they said something like, y varies jointly with x and z and inversely with w. Always going to be y equals k. K is always in the same spot.
Mm-hmm.
If it doesn't say directly, but if it doesn't say inversely, that means it's direct.
Okay.
So if it varies jointly with x and z go right here together. And inversely with w, so w's on the bottom.
Okay.
That's it. That's all of 9-1. 9-1 should be pretty much a breeze. I do want to draw your attention, though, to number 11 in the guided practice. Because this section says, tell whether x and y show direct variation, inverse variation, or neither. So, to solve these problems, you need to see if you can put it in this form. That's it. If you can put it in one of these forms, that's what it is. But, for like number 11, change colors.
Number 11, you'd be subtracting.
Right.
Oh, I think one of the previous students who owned this book wrote all the answers for this.
Oh, gosh. Okay, well, do your best to, because they won't have been able to do that on the test. Okay, so here it wants to know, this is number 11, is this direct, joint, inverse, or direct, inverse, or neither?
Oh, so you can just solve.
Right, you could just do y equals negative 2x plus 4. This right here is not in any of these. So, neither.
Oh, I see.
Does that make sense?
Yeah.
Okay. Guys are good?
Yep.
Okay. Excellent. Yeah, then I just want to do number 36. I'm going to erase this because I don't even think this is in your homework. Does anybody still need it?
Nope.
So number 36 gives a table of values. So you have x and y. So 31 to 17. 20 and 140. 17 and 119. And you have 12 and 84. And it wants you to do the same instructions. Tell whether this is direct, inverse, or neither, as far as variation goes. So, direct is y equals k times x. So to get from here to here, 217 equals k times 30. So k would be equal to 217 divided by 30. I'll grab my calculator. So for this one, k is 7.23 repeating. So if that's true, if this is direct variation, k will be the same for every single one. So I'm going to test another one. So 140 equals k times 20. Divide by 20, divide by 20. Oh, well this one k is only 7. So it doesn't work because the k is not the same.
Wait, so what are you trying to, what's the question?
Is this direct variation, inverse variation, or neither?
Okay, and it's neither because k is not constant.
Well, so far it's just not direct. We still need to test inverse.
And
but
it's not direct because
k is not constant. Okay. So now we're going to try y equals k over x. So y equals, or not y, 217 equals k over 31. So in this case, multiply both sides by 31. 31 times 217 is 6,727. 6727. Okay, so now we're going to test it again. Is 140 the same thing as 6,727 divided by 20? No. In this case, you would get 140 does not equal 336.35. So now we know it's neither, because we tested out direct and we tested out inverse, and neither one of them have a constant k.
Okay.
Does that make sense? Excellent. Okay. So, any questions about anything I just taught you from 9-1? Good.
Sorry, I understand everything you did.
Uh-huh.
I don't understand how you used the tables.
I just took my x and y values.
You just took any x and y value.
I just started with the top two. Because if it is a direct or if it is inverse, I can go through every single one of them and set them up the same way, and k will be the same thing.
Oh, so if you compare the first set of x and y and the second set of x and y, k should always equal the same number, no matter what it is.
Technically, you should keep going. Is this like one of those ones where it's like, is this point a solution to the set? or to the system of equations. Just because it works in the first one doesn't mean it'll work in the second one. And it has to work in all of it to be the solution. So technically, if you did get the same k for the first two, you should also test the last two.
Is there a calculator function for this?
No.
Because that's a lot of testing.
Well, you only have, I think, 2 problems like that.
Okay.
So it's not going to be that bad.
Well, and you can do calculator too, so it's not like...
Yeah, I mean, it didn't take that long, only a minute or 2. Okay. So now we're going to go into 9-2.
This is 9-2.
Well, that was 9-1.
Oh, that's still 9-1.
Yeah.
Okay. 9-1 is just variation. 9-2.
Graphing.
They have
Oh
Stephen,
no, we're back to
have Stephen
graphing.
Hawking right here.
Already?
Seriously? Where's that?
Wait, yeah.
Oh,
Five
you know he
seconds.
just died.
Yeah,
Yeah, he did.
You know what I was wondering is, he always wavered back and forth between believing in a god or not believing in a god.
Mm-hmm.
I wonder how he died.
We will know someday.
Hmm.
Okay. So,
Why is like always the first thing? It's like here's a nice equation, and then now graph it. It's like, oh.
all right. So a rational
graph.
function. Is it R of the x? No, they do f of x. F of x equals p of x over q of x. So you know how to graph f of x equals anything. Now we're going to stack 2 functions on top of each other. So what happens if you have 2 functions happening at the same time? Okay. So the parent function for this is y equals 1 over x. And that's how this is related to 9-1, because that looks very similar to inverse variation. Yes.
Mechanically, wouldn't this be the same as polynomial division for the function, or I mean any kind of
Yes.
function division?
We're just
You
not,
just apply that.
we've just never graphed them before. This is all about graphing them.
But those can divide into a single function, right?
Not always.
Okay.
Sometimes you can have a remainder, and that remainder would have to remain a rational function.
Okay.
Okay. So, to graph this, you can think about it. Okay, first of all, what would happen if I plugged in 0? If I plugged in 0 for x, what would I get?
The origin.
No.
Oh,
What's-
I mean, y equals 1 over 0?
Which
0
is-
can go into 1 infinite amount of times. Right?
No times.
Or
This is,
no
it's
times.
impossible.
You would
Yeah.
not
So
get a point.
error.
Error. You would not get a point. So if I plugged
So
in
it
0
doesn't
here,
start
that
at
becomes
0.
error. Right. What if I plugged in 0 for y? So 0 equals 1 over x.
That's still error.
Still an error. Does that make sense? As 1 divided by no number at all will give you 0. So what ends up happening is asymptotes.
Oh no.
So an asymptote is an imaginary line that we usually graph with a dotted line that represents values that the function can never have. So here, at x is 0 and y is 0, we have what are called asymptotes. And graphs behave very predictably when they approach asymptotes. So if we were to plug in 1, we get 1.
They just get infinitely closer.
They get infinitely closer. But in this case, it has 2 asymptotes. So it gets infinitely closer there, and then infinitely closer there.
That hurts my brain.
But then because if we just made x negative, the only change would be that y is now negative 2. It also does the same thing over here. And that is the graph of y equals 1 over x.
Wait, so asymptotes are lines that the graph can never go on? Is
Right. That the graph can never touch. Okay. So, just like all of our functions with the a, h, and k, that is how we talk about transformations for rational functions. So, a still makes it stretch or compress. So A is a stretch or a compression. H is a horizontal shift. In this case, though, because this is x plus 0, really, right? And we know that x plus 0, x cannot be 0. That's also going to be a vertical asymptote
Wait.
at x equals h.
Okay.
Because if it were like 1 over x minus 2, x could never be 2, because you would get 0 in the denominator.
So, right. Okay. So it shifts. It doesn't shift the it shifts the asymptote of the graph.
It does.
It doesn't really.
So when you're graphing, the easiest way to graph these with the shifts is to graph the asymptotes and then just draw the graph hugging it.
Mm-hmm.
Okay, K is a vertical shift. That is also a horizontal asymptote. At y equals k. And then if you have a negative a, you know that flips it. Flips graph. Okay. So, doing an example.
Wait, so for K, you said vertical, you shifted vertically, and then horizontal asymptote, what does that have to, is that referencing K?
It's referencing H. A vertical asymptote, okay.
Right here.
Horizontal asymptote, y equals k. Remember, horizontal lines are a constant y value, so they're always defined by y equals some number.
Okay.
K shifts the horizontal asymptote.
Okay. So, like, let's do blue. I like the marker. Okay. So, example 1. Graph y equals -2 over x plus 3 minus 1 state, domain, and range.
Are the operations still inverted for h?
Yes.
Okay.
Still
So we're going to be going
h
back
k.
3.
Right.
We're left 3 on the...
Nice job. Okay. So we've got our axes.
Oh, because it's in the fraction?
Left 3 and down 1.
Is it because it's in a fraction that it goes to the...
No, it's always, like, if we were dealing with the quadratic function, y equals a times x minus h squared plus k. X is always going to move the opposite way of the sign of h.
Okay.
So, yes.
For stretch and compression, for A, in this case, does it, like, make the curve sharper or narrower?
It
or,
does.
I mean, sharper or...
Are you asking me which one, or if it just has that effect?
Does A have that effect
Yes.
of making it the curve sharper or smoother?
Yes, it does.
Okay.
So now what we know is that our graph is going to shift 3 to the left and -1 up and down. Does that make sense? So we're going to graph our asymptotes first, because that's going to be the easiest way. So we know we have an asymptote at x equals h. Well, in this case, h is -3, so x equals -3 is a horizontal asymptote. Or excuse me, vertical asymptote. Does that make sense? Just pulling this out.
Mm-hmm.
Just keep going.
Okay. Now, my horizontal asymptote is going to be y equals k. Well, here, k is -1. So I know that I have a horizontal asymptote at y equals -1.
A is negative, so that's going to have the graph be all like upside down in the bottom left corner.
Right. It would have been up here, but now it's flipping down here because A is negative.
Oh, wait, but then what flipped it to the bottom left?
This side will flip up. Because these were all negatives, but now we're negating a negative, so it's going to become positive.
Right, but how could you go from top right to bottom left? You'd have to do a -2 plus something else that would flip it vertically, like this.
I'm sorry, I'm confused what you're asking.
Well, because the first time you showed us it visually, you drew one on the top right.
Yes, and one on the bottom left.
Quadrant of the graph. And then you drew one on the bottom left quadrant.
Right.
And doing a negative goes top right quadrant to bottom right quadrant.
Right.
So how do you go from right to left?
You don't.
Then how did you draw?
It goes like this. They're in the first quadrant and the fourth quadrant to just flipping.
Oh, so what determines if it's in the first or fourth?
Well, they'll always be opposite the origin from each other.
Mm-hmm.
They won't be stacked next to each other.
Oh, it's going to do two graphs.
Yes.
Oh, so the one function has both of those graphs.
Yes, it has two branches.
Oh, okay.
I see what you're saying.
Okay.
That makes it so much different.
So instead of it being 1, 1 away from here, now it's going to be 1, 2 away. Does that make sense? So then you just have to do this. 1, 2. So that 2 results in it being farther away. Oh, it should have been like that, from the origin.
Wait, what? Where's that dot supposed to be?
So it would have been up 1 over 1. Now it's up 1 over 1 up 2.
Over 1.
What? Okay, so I thought A made it sharper or smoother, but
it does.
Changes the
pulling it away.
Right, but how? I guess what I was thinking in my head is the scale of the graph.
Right.
So
it's still going to approach the asymptotes the same way. The only way it affects it is right here on the origin.
You only need to find 1 point to get both.
Let me see if I can mess with it on Decimals
as long as you
bit
find
to
that.
see what.
Yes. And
okay, so yeah, I don't know. I still get confused with whether you know if it's going left or right.
Okay, and I think we're just gonna stop there. And 9-2 we're gonna do in combination with 9-3 on Monday.
Okay.
So homework will only be from 9-1. So starting on Monday, we'll start reviewing 9-2, and then we'll go into 9-3.
Okay.
Does that make sense?
Mm-hmm.
Okay.
Mm-hmm.
Okay. So that's
I don't know
it.
if I